Hello everyone, welcome to the IT for Biomedical student series. It's part 5. So here we're going to look at the title called What is Subnet Mask. Previously we looked at what are the network addresses, IP addresses, and the IP address is two portion. One is the network, another one is the host portion. So we will look at the what is subnet mask, why it is done, how it is done. So why do we need subnet mask? Because we usually see these are the places where we see the subnet mask. If you take any IP, any computers or any devices, you'll always see a placeholder to put your IP addresses and also a subnet mask. We do know that we do know that IP addresses are being used to identify the devices, like an addresses, right? Like in home addresses. But why do you need a subnet address? If you see this in every devices, you see this in every industry devices, any industry devices, even the PCs and so on. So that's what we're going to look at in this video. Something what we discussed at the previous video, that we took an IP address like as an example 10.3.3.2, and we said, and this 10.3.3 belongs to network address and 2 belongs to host address. And when we said that, we meant like this portion is like a street address and this portion is like in a door number. That's what we said, like to give you an analogy. So if it is the case and every address is in the same network, and it means like they all in the same street or something like that, and you have different houses, so it tells you that you part of one community, right? So how do we, how did we define this? How did we define only this 10.3.3 is a network and .2 is a host? Can we just say that 10.3 is a network and the 3.2 is the host? Can we say that? Yes, we can. But how do we say that? And the answer is the subnet mask. So using the subnet mask and this IP address correlations, you relate them, and then you define what is a network portion and what is a host portion. We will dive deep into this and to see how it is done. Again, we are dissecting the subnet mask, as I said before. So let's take an IP address. This is an IP address we are taking, 10332, and we're taking a subnet mask with this 255.255.0. With these together, what it says to us, like it tells us that 10.3.3 is a network address and 2 is a host address. This is what it is telling us. So we're going to look into it now. Let's take the IP address 10.3.3.3.2 and subnet mask 255.255.0. With these two, somehow you might have come to a conclusion that everywhere it is 255, that belongs to a network address, and everywhere it is 0, it belongs to a host address. If you had come to this conclusion, it's kind of correct, but we this is okay, correct. But suppose you have, instead of 255, if you have 254, then it's not correct, right? It's not correct. So how do we know that? How do we find it? By using the binary transition of this. So I'm going to take a little bit deep dive into it. So let's take an binary equivalent of the IP addresses and a binary equivalent of the subnet address. In here, you can see that all the ones on the subnet mask, which is correlating to the IP addresses, belongs to the network portion. So let me change this. If you see this, all are ones, and those thing which is corresponding to the IP addresses, these belongs to the network. And wherever you see zeros and its corresponding digits, binary digits in the IP addresses, they belong to the host portion. So if you take a look at it, it would just give you a clear idea. Why do we say this portion? Why do we say this portion is a network address, and why do we say this portion as a host address? Like here. Sorry for that. So like this. So we say that, this is a network address, this is a host address, right? So this is why we say that. If you take a deep look at it, you'll understand wherever you have one on the binary of subnet, and that corresponds to the which is equivalent on the IP side part, belongs to the network portion. I'll clean. Just take a look at it for a moment, and then you will understand. We'll also see one more example on the later stages of the slides, and that will give you a bit of a more idea. So this is what I've just said in before, like all ones in the subnet, network defines network portion. All subnet defines network portion. I'm sorry for that blabbering. All ones in the subnet defines network portion. All zeros in the subnet defines host portion. As simple as that. Okay. We saw that, like, it has a IP address and subnet mask, but what we see that in the bigger picture, we saw in the depth of it, but what we see in a bigger picture, what is the use of it in a bigger picture, right? This is like a use of having a subnet mask, right? That's what we're gonna see. What is really useful, how it is useful in our real life. So if you define the subnet mask, we are taking an IP address. If you are defining this subnet mask for this network, I mean host address, what we are saying is you have different networks, and each network starting with like this 10.1.0, and then this is the network portion, right? And then 0 1 2 3 4 to 5 4 to 5 5, and then the next address will be like 10.1.3, and then 0 1 2 3, and then goes to 5 5, and same on for network 3, and till all the networks available on this particular 10 dot series. So when we said that, what do we mean by this? What do we mean by this? Like, we are saying this particular portion is a street 1, this is a street 2, and street 3. They are isolated. Just remember this, they are isolated. Each network is isolated at the beginning, right? Always isolated, but you can make it interlink. We will discuss that. So when I say isolated, what happens is, if this guy, like say that this is a PC1, right? I mentioned it here. So he wants to send the data to everybody at one shot. Like, hey, my name is PC1. I would like to know that my IP address is 10.1.1, 10.1.2.1 to everybody. Or he wants to send a packet. He wants to send the data to everybody. He can send it to like everybody. How he can send? He says send one broadcast message, and it reaches everybody. Can he send a message from PC1 to like everybody in this? The answer is big no. He cannot send a broadcast from network 1 to network 2. No broadcast. No broadcasting will happen. You cannot send the broadcast message to everybody outside your network. So that's one reason why you have different networks, because the devices in a network are like always have the thing to send broadcasts for so many reasons. So if you send the broadcast to everybody on every network, it will jam pack the other network. So that's why the people always say isolate my network so that I don't get the broadcast from the other networks. So this is a commonly used words. People always say that. So let's say that this guy here wants to send a message to just to this guy. Can he send? Yes, he can. So direct. So that's called unicast. That's answer is yes. This guy wants to send a message to him. Can he send? And think for a while and let me know. I know I'm not in front of you, but I'm just saying, tell to yourself. Sorry for that. So the answer is yes and no. What do you mean by yes and no? The yes meaning no. Why? In general, the answer is no, because you can't send a packet from one network to other network. But if you make inter-VLAN routing or in routing, like, or the routing process, If you make the routing properly, then the answer is yes. If you do a routing and you can do 10.1.2.1, 10.1.3.2 communications, you one to one. Who does this routing? Where the routing is done? The routing happens at the layer 3 devices. You will get to know when we go to that bigger topics in the later series of the video. But for now, I want you to understand that there is a concept of routing that should be enabled, that should be done on the network side, not on the PC side. This network routing configuration is not done on the PC side. It is done on the network switches and routers. I mean layer 3 switches and the routers. So you don't need to be worried much on the PC side. So then only you can talk to each other. Another question may come. Okay, now that we have done the routing, can we send a broadcast from this particular machine to everybody here? Answer is no. You cannot send a broadcast between the networks. You can only send the unicast, and then the multicast goes among the networks. That goes in a different way. So that's it. I will erase the ink for you all. So take a look at it. This is network 1. This is network 2. And this is network 3. And it goes on and on and on and on and on and on and on. But how are we defining this? Because of the 255.255.255.0. You know, you don't have to do like binary conversions every time. There is another way. I will show you also in this series. So we are taking another example. For example, we saw like this 255.255.255.0. Now we're going to see what if it is only 255.255.0.0. In that case, this portion is the network portion and this portion is the host portion. Again, we did the binary conversion, and now you can clearly see that the bar has been, I just moved the bar to the left, and all the zeros are here and all the ones are here. So that tells this is the network portion and this is the host portion. So as simple as that. So every time you the numbers are changing, you have to just move. Is it something like it is always will be like 255.255 or 255.255.255? No, there are chances that it will become 255.255.254 also. But how do you do that time? Is that like I have to do every time with the binary conversion? It was the case before, but now we have so many calculators available online, so that can help you do that. We will take a look at the calculators as well in this video. Some of them are available online. As I said, 1 in subnet defines the network portion, ones network portion in the subnet, zeros in the subnet device host portion in the IP address. So I kept this place blank so that I can take you to the online and show you how we can use an online calculator instead of using this 1-0 conversion. So here I am at the Google. So if you can see this, I just Google like subnet calculator and I'm just taking the first one. So here we are using network classless. There are different ways class. We are not discussing the class A, class B, class C in our classes. Usually we are using all classless, so I'm putting any. So here let's give it an IP address. Same example, maybe I will take 10.3.2.3. Okay, this is an IP address of the device. And here I am going to choose 255.255.255.0. Okay, so this is what we did on our example. So let's do a calculation. So if I do a calculation now, it gives me, so this is an IP address what we just gave. What is the network address where it starts with, and how many IP addresses we can use? For example, 10.3.1 till .255 I can use. This is totally 255 addresses I can use. So they're mentioning that these are the host addresses. So number of usable hosts, meaning we can assign 254 PCs or 254 medical devices in this network. 250 medical devices can get an IP address in this range in this network. What is the broadcast address? This is the broadcast address and this is a network address. As I said, these are the two non-usable IP addresses which you cannot assign to the medical devices. And here is the subnet mask. Right? Some people sometimes call it as a /24 network. Instead of they saying 255.255.255.0, they will say it's a /24 network. What do they mean by that? If you count all the ones, it will come till 24. So that's why this is like CID notation. They just call it /24. Previously also we saw that whether the IP address is a private or public or whatever it is. So it also mentions that it is a private IP addresses. So this gives you some kind of an idea, right? How things works. Let's say that let's take instead of 255.255.255.0, we will take this. If I do this, see for now we can use only 250 for IP addresses, right? See how it changes. See, again the IP address, the network address is like 10.3.0.0, and then this is the broadcast address. We can use IP address from 10.3.0.1 to 10.3.255.254. In this range, there are these many IP addresses available to use. Sorry, so that's a total address. So these are then because you need to minus 2, because one is this and one is this. So if you do that, you have got 65,534 IP addresses to assign to a devices in that particular network. Does people use this practically? No, people don't use it much. They don't use it much. You can't use these many devices. If every device is sending data, broadcast data, it's gonna jam pack your network. But it's just an give. I'm just giving an example. Let's just take another one. We saw slash 24. We will take slash 23. There's sometimes people do use it. Here you see you have 10.3.1 to 10.3.3.254 network addresses you can use, and you have 512 total addresses and 510 usable addresses. All right, so this is slash 24. People do use it, but it's kind of they do use it, like it's not like unrare, but they do use it. So this is how you can figure out where your device IP address is, what are the range of IP addresses you have in that network, and what you can use, what you cannot use, and this is how the subnetting works. You can use them, these are available. You don't have to do that one and zero things these days. This one will just help you to figure out your subnet mask and the number of usable IP addresses in that network. So having said that, we will go back. So what is the takeaway in this? We just looked at what is subnet mask, and then when you convert that into ones, and how does it look like, and how it is related to the IP addresses, and how it divides the IP addresses into the network portion and into the host portion. And we also looked at we went to online and we looked at how does we can use online calculators instead of going through the papers with ones and zeros. And thank you for your time. And again, if you have any questions, feel free to write me an email or put a comments onto this. We can discuss this anytime. Have a great evening. Bye bye.